To Keith, who will be doing tonight's presentation. Keith?
Oh, welcome, folks. And today I'd like to be talking about digging the Marl of the land's formation. We'll be talking a little bit about sedimentology, some geology, and our friends, the dinosaurs. So let's get started. This is what the area looks like and still looks like, except the picture with the derrick on the far right side. The derrick is finally gone after 2 years of tear down. Land formation was first described in 1903 by John Hatcher, named after geologic exposures near the Lance Creek of all places in Wyoming. Um, Pretty much the Lance formation is pretty much in Wyoming only to my knowledge. It's a geologic unit from the Late Cretaceous period. It formed approximately 66 to 69 million years ago and is exposed in western United States. Um, it is the uppermost Cretaceous unit of the Powder River Basin, which covers pretty much most of the northern part of Wyoming in itself. At that time, the western interior seaway started receding about 70 million years ago and continued receding until the Paleocene. There are signs of that, and we'll cover that a little bit as we go along. The KT boundary, even back in 1912, was trying to be determined where it was. They believed that was the lowest persistent lignite or coal beds that overlays the highest occurrence of dinosaur bone remains, uh, more or less covering the KT boundary. Come on, you can do it. Okay, there we go. This is a wonderful map of Wyoming. It gives you the geological layout of things. See if I can get my screen to reduce so I can see what I'm showing you. In the upper right-hand quadrant, you can see the area in which we'll be discussing today. To give you an idea what else is around, if you can see my cursor, the town here of Sundance, just a little bit to the northwest of that is Devil's Tower. And also you see Newcastle, just a little bit off the screen is Cave of the Winds. Starting from left to right, there's several different types of formations. The Wasatch Formation, which is Eocene, which existed 34 million to 56 million years ago. Fort Union Formation, which is Paleocene. The Lance Formation, which is also broken down into different layers. On the most part, let's see if I can get the colors right. This is your Paleocene. And next to that is your Upper Cretaceous. And Upper and Lower Cretaceous is over near Newcastle, where my cursor is. And generally where our search area is in the Upper Cretaceous or Late Cretaceous, depending on how you like to declare it. Wyoming is geologically incredible. There are places on the far west side of the Bighorn Mountains, which has Morrison Formation, which is your Jurassic. You can probably find some of the colors in there for it. There are a few quarries that are working there and some significant things that have been found in the past in that general area. What is Marl? Basically, it's a sedimentary rock. It's composed mostly of sands, fine-grained clays, silts, and calcium carbonate. It's formed in both marine and freshwater environments. The calcium carbonate, which is very interesting, a lot of it is formed from, of all things, algae. Photosynthetic aquatic plants tend to remove the calcium dioxide from the water and it participates down to the bottom or in layers. A great example of this, if you ever get to go to the Green River Formation and the quarries over near Kemmerer, most of that's carbon dioxide or calcium carbonate that forms is more marl. And in fact, if you were to smell that rock, I wouldn't suggest it if you have it at home. It smells very oily. It's very biologically dynamic. Very interesting location. Nodules can be common due to the presence of clay minerals. In fact, there's a lot of what is called mudstone in that general area in those layers. Compared with Hell Creek Formation, which consists of hard-packed gumbo clays, the Lance Formation consists more of sand and sandstones. But if you ever go collecting in those areas and it's raining, you're not going to get out the door. It's truly gumbo at both locales. The Powder River Basin, based on geophysical logs, gives you an idea what the area is like. The channel sandstones can be 20 feet thick or thicker, made up estimated about 30% of the Lance Formation. The 70% is composed of thinner sandstones and finer grained interfluve sedimentary rocks. Now, what are interfluve? These are rocks and sediments that wash down from into valley areas where there is moving waters. This is the best way to think of it. Whoop. This is part of the dig site. It's quite large. I would say it's at least 2-3 acres in size. And this is a general breakdown where I did most of my digging for the teeth and small bones. It's very fine grained. In certain areas, the sandstone has been, in effect, cemented from chemical reactions. So it's very hard to work with. In fact, if you may notice in the small blow up, you'll see streaks within the sandstone. We had to use rotary hammers to get the overburden of hard sandstones to get to the layers to where the fossils are located. But the bone and tooth preservation is excellent, despite the fact that this is an old channel deposit. Now, what happens in a channel deposit? Things get tumbled, they get broken, they get polished. Things like serration of the teeth can be washed away. For some great reason, a lot of these characteristics are maintained within the fossils themselves, so they turn out very nice. We do have a cap rock. Working your way down, you run into the chemically hard sandstones. Then you start getting into softer sandstones, and the further you go down in the sandstones, you start running into nodules of clays to shales and mudstones. The further down you go, the marl changes. You get gray clays, and then you go further down, you're running into gray clays and a very hard greenish clay. Depending on areas in the site, you can also run into what seems to be more like limestone than it is a sandstone. It's very hard. A rotary hammer wouldn't penetrate it, even if it's just 3/4 of an inch thick. This is what some of the sediments look like. You can see in the red boxes some of your hard clays or shales. If you were to break those open, you'd see a lot of plant mash, which seems to be consistent whenever I've run into this type of shaly clay. But intermixed with that is the sands, and the sands are one of the places you can find teeth, you can find fish scales, especially gar scales, and bones and other things. Sometimes they're plastered against the clays and shales. As you can see in the picture in the blue, I didn't know what I ran into until I got it out, and it is a very well-used T-Rex tooth. In fact, on the far left side at the bottom, you can still see the serrations. Part of the route is still existing, but this one did not get spit out. It got worn down very nicely. Now, what is northeastern Wyoming like today? It's semi-arid climate characterized by long, hot summers and cold winters. There are quite long lengths of drought, followed by not so long lengths of rainy periods. But when it rains, it changes everything. The whole area turns green and turns very beautiful, and some of the wildflowers start to come up, which sometimes don't show until 5 years later. The temperatures during the January, the average is around 12 degrees Fahrenheit. It's strange, you can have snow, and that snow still will be melting and turning into vapor. And then during the summer, 79 degrees is average, but when I've been collecting during the summer, especially in June or July, it can get up in the hundreds. It's a grassland, although I would say it's more of a sage land. There are cactus. It is located near the western edge of the Black Hills, which is a totally different time period, and there's some rather significant things being found over in the Black Hills as today. I remember some time ago, what was that? There was a boar or the killer pig, I can't remember the name of it, was found not too far from the office of the Black Hills National Monument. Kind of animals you can find are reptiles, mammals, believe it or not, amphibians, and I'm not talking just toads. This is a tiger salamander that we found in the dig site. If you stretch this puppy out, it'd be 10 inches long. So you never know what you're going to find in the desert. Wildlife is not as frequent as like here in Illinois, but there's wildlife there. Deep time of lance formation consists of many environments, especially in the lands. It was a semi-tropical climate with seasonal wet conditions. It was pretty much a coastal floodplain consisting of swamps, lowland forests, estuaries, extensive shallow river systems, which kind of complements the area when we go collecting, because one of the things you're always looking for are things like fish scales or small parts of bones or turtle shells. And you will see that scattered on and off throughout the lance formation. Compared to the Hell Creek, lance is more coastal, fluvial, and more aquatically dynamic. And when you start seeing the bones that are found there, you will see that those bones have been tumbled in some fashion. It's a complex, low-lying floodplain. Fossil record indicates there was a wide range of life, which is indicative of the fossils that we are finding there. We have found not only dinosaurs, we have found reptiles, we have found amphibians. And that's just the animal life, not just the plant life. At that time, we did have flowering plants. The animals that were included were your regular dinosaurs, were both herbaceous, carnivorous, and omnivores, and along with birds. Although I haven't seen anybody find bird bones yet, it would be very exciting to do so. Reptiles, we have your crocodiles, alligators, champsosaurs, many types of turtles and lizards. The amphibians mostly were salamanders, but there are records of frogs being found. Freshwater fish include the gar and the bowfin and skates. Skates are like your stingrays, but a little bit different. They're older than your stingrays that we have today in structure of their bodies and such. You also can find mammals, the multibivaculates, the Delphodon, and marsupials can be found. Don't want to work that way. We'll go this way. Whoops. One of the most common of the fossils you can find in the Lance Formation are Triceratops. There's two general species. There's more than just the main two, but these are the most found in the Lance Formation. Horridus and Porosus, if I'm saying that correctly. I don't speak Latin. They date back between 69 and 66 million years ago. Again, they're the most common dinosaur found. They're herbivores. Its genus names translate to three-horned nose. They are quite large. They can range from 26 to 30 feet in length and stand 7.5 feet tall and weigh as much as 11 tons. There's a project that's ongoing. If you ever want to look into it, it's called Triceratops Gulch Project. They invite the public to come and participate. So it's something to keep in mind whenever you go into Wyoming. I believe some of their sites are near Casper. So what do Triceratops fossils look like? Let's see if I can get this to go. First one is a spit tooth, you would think, but this is a spit tooth with root, which means, in effect, this was a tooth that had tumbled out in the current of the channel and got buried quick enough to preserve its structure. Just below that is a small trike vertebrae. Another sign of the dynamics of the channel deposit, or the channel it was deposited in. Only about 30% of the surface of the bone exists. The rest, you can see the cellular structure of the bone, if you can see that close enough. The next one is the metatarsal. That is one of the toe bones in the rear leg. Metatarsals, and there's metacarpals. They're structured a little bit different, and that's how you're able to tell the difference between front legs and rear leg toes. The next is a calcaneum. Now, what's a calcaneum? You have your tarsal, which is kind of like your ankle bones, and then there's your metatarsals, what we already talked about. I was lucky enough to find one that's nearly complete in the channel deposit. Next of the herbivores is the hadrosaur. That also dates back to about 69 to 66 million years ago. Predominantly represented by the non-crested genus Edmontosaurus. They get quite large. Their jaws can contain as much as 1,400 self-sharpening teeth. And you can see an example of that below. The genus names translate to stout, thick lizard. Everything to them was lizards, I guess, back then. They can be 39 feet in length and weigh as much as 6 tons, which is quite a large animal. It was named by Joseph Leidy in 1858, quite some time ago, so it's been discovered a long time ago. The example here is, first off, is a not even juvenile, a subjuvenile lower mandible. I believe this would be the right mandible. Next to it are the teeth. One is rooted and the other one is a spit tooth. Now, what is a spit tooth exactly? Dinosaurs, your theropods, pretty much had a nonstop production of teeth. They rose in rows, as you can see in the jaw example. Normally, there's a plate of bone over this. So what happens is your teeth keep progressing out. They break off, they get spit out, thus they're called spitters, and the system just keeps replenishing the teeth. Next, we start on our theropods. There's quite a few theropods in the Lance Formation. In fact, we have seen so many different, we were very surprised in this channel deposit to see what type of theropods we have run into. Most of the time, you're going to find teeth. You do find claws. The examples here are the top one is a small tail vert, and the second picture is a small claw, probably one of the toe claws of the what you would call the hand. The rest are various teeth from the various locations in the jaw. If you look close enough, you can see serrations, and they have a very wonderful color to them. So they were very well preserved when they got deposited. Dromaeosaurs dates back to 80 to 66 million years ago. They are relatively small bird-like carnivores. They were up to 6.5 feet in length and weigh around 35 pounds. To give you an example of today's carnivores, the American eagle has an wingspan of about the same length as my arms, as much as 6 feet. And the female, which is about a quarter larger than the males, weighed about anywhere from 11 to 12 pounds. So there's not a big difference in weight. You got to remember, theropod bones are very strong, but very thin to give them less weight. Let's see here. The genus name translates to running lizard. They have the sickle claw, just like we see in Jurassic Park. Something to keep in mind, the claw that you see in the picture or in the images that are presented, those are the bones. Now add 40%, you see actually the full length of the claw. So this little one was about a quarter-inch long bone, or I'm sorry, half-inch long bone. The actual length of the claw when it was alive was about an inch long. Dromaeosaurs were first discovered in 1914 by paleontologist Burnham Brown. It was during an expedition up into Alberta, Canada. The location was the Red Deer River. Next of our theropods is the Parachodon. I was saying it right a couple hours ago. I don't, I have a problem with Latin, thank you. This theropod dates back to 100 to 66 million years ago. Is known to be in the Lance Formation of Wyoming and Hell Creek Formation. That includes places like the North Dakota, South Dakota, and Montana, where you have Hell Creek Formation available to be collected or researched. Originally, it was thought to be a mammal and was placed in this group by George Olszewski in 1991, which is relatively recent. They don't know what the actual animal looked like. The only thing we have are the teeth. There has not been a jaw bearing teeth to match up with an animal. The genus translates to beside claw tooth. I don't understand, but okay. It was named by Albert Drinker Cope, 1876, and it was found in the Judith River Formation of Montana. It's very unusual teeth. They're ranging in size from about a quarter-inch to an inch. Next theropod is Ricardostetsia. It has a very long history. They believe this species or the genus has existed since the late Jurassic. The holotypes consist of a pair of lower mandibles that was found in the upper Judith River group. I believe that would be Montana. They guess the size to be about 220 pounds. And it was named after Richard Estes for honor of his work with small vertebrates, especially theropod teeth. He also was very well known for his research in salamanders. Let's see here. They believe it's the longest lasting dinosaur genera and also most widely distributed, considering that it is found from Montana to Dakotas to Wyoming, possibly Utah. Next one is Troodont, which is a very unusual looking tooth if you see the photos. It's a relatively small bird-like animal. They presume that it is an omnivore, or yeah, they assume it's an omnivore. It existed between 72 to 66 million years ago. They think it was up to 10 feet long and weighed about 110 to 220 pounds. The name translates from ancient Greek to wounding teeth. Their teeth are different from those of other theropods known at the time of their discovery. The morphology makes them think that it may have been related to a herbivorous reptile instead of a omnivore or a carnivore type reptile. So that's one of the reasons why they think it may have been an omnivore. The structure of the tooth is very different in comparison to all the other theropods of that time. Another interesting thing about the Troodont is the forebrain. When you are able to have the complete skull, you're able to determine what the brain shape was. And the brain shape, the forebrain especially, for non-avian theropods was found to indicate that it was very intelligent. And the species that was found with the complete skull was found in Alberta. So they believe that the Troodont was one of the most intelligent terrestrial animals of its time. Next one we all know about. We have Sioux that is in the Field Museum. T-Rexes ranged from 72 to 66 million years ago, was an apex predator. The most complete specimen measures 40 to 41 feet in length. T-Rex, they believe, could have exceeded 43 feet in length, and it was 12 to 13 feet at the hip, which generally you got to remember that they were bipedal, and there was kind of like a balancing point at their hips. They range up to 8.8 tons, which is quite huge. The name Tyrannosaurus comes and breaks down to king of the tyrant lizards. Now we get into new realms. I had written this before we got into Jane at Burpee. They believe Jane now is a new species of theropod. They believe it is a nanotyrannus. I believe the name is Lethiensis. We also have another tyrannosaur, Lanciensis, which is what this is referencing. I believe Lanciensis was one of the dueling dinosaurs. Field Museum has been researching this for quite some time. This publication came from January 3rd of 2024, which is relatively recent. The examples I have here are of very small teeth. I believe they're not the prime front teeth. I think they're more in the back area. Then we get into reptiles, crocodilians. The examples we have here are modern day crocs, so you get an idea what their physical structure looks like. They're all a little bit different. I won't even try to go and try to pronunciate these names of lance formation known crocodilians. They date back from 69 to 66 million years ago. They are most certainly carnivores. They could be as much as 30 feet in length. The ecosystem where they lived was in part moist and forested floodplains. They are discovered in Wyoming and Montana. Their name translates to stone worm from ancient Greek. For some examples, Brachiochampsus has a little bit different eating habits than your regular crocodiles. If you notice the picture in the center, the teeth are rounded. They were crushing teeth on the most part in the back of the jaw. They also had scutes like today's modern crocodiles, and these are examples of scutes. Those are the armored plate type bones that run along the edge and backs of the crocodile. You can see there are certain examples of the teeth. For the longest time, folks were telling me some of the teeth were actually fish teeth, but bowfin in particular. But actually, the teeth are different compared to the top jaw and lower jaws. So lower jaws were more pointed, and the upper jaws were more pointed, and the lower jaws were more rounded. Now, why do I have this big chunk of bone in here? Actually, this is part of a Triceratops frill, and the significance is these little dots. It seems that a crocodilian decided to bite this frill, and the damage of that is showing in the fossil. Next is the Champsosaur, another reptilian. Notice the date is 75 to 55 million years ago. So they survived the asteroid hitting in the Yucatan. They were carnivorous. Most species grew to about 5 feet. And in fact, there's a very nice example that is at the Burpee Museum. They do range as long as 15 to 12 feet long. It was named by Edward Brinker Cope in 1876. They were prolific in describing and finding fossils during their time period. The genus name is thought to come from the Champsi, which is ancient Greek source to be Egyptian word crocodiles, and saurus, your Greek word for lizard. So you can't say the names are actually true Latin. In this example, there's 2 different vertebrae, and along with one of their teeth. You may notice there are lateral lines in the teeth, and that's how you can tell the difference between Champsosaur teeth and your crocodilian teeth. Next are your lizards, your tidy is how you pronounce the name. They existed from 69 to 66 million years ago. They were herbivores. They could be as long as 31 inches in length. They're known as whiptails in modern day and at that time. A new species of tidy was discovered in 2002 in Utah's Cedar Mountain Formation. And this is an example of what their jaws will look like. One of the teeth had broken off, and I believe this little long line may have been a part of bone that would be against some of the teeth, which had fallen off. Next are your turtles. Most of the turtles there were soft shell. I won't dive into the names. Some of the lineages lasted into the Eocene time period. One of the interesting characteristics of your soft-shelled turtles, they had very long necks. Some of them could be as much as 3 feet long and weighed over 220 pounds. I was lucky to see somebody encounter one of these turtles in the lance and was able to bring it home. It was about 30 inches long. quite a large and quite interesting because their structures of their shell is different. If they are a male or a female, they have different characteristics. All these were aquatic. Some had high domes, some had thicker shells. Most of the time when you are collecting, you will find many, many bone bits or shell bits of turtles. And these are pretty much mostly aquatic type turtles. An example here is a small piece of shell of one of the soft-shelled type turtles. There also you can find the claws, the digits. Let's see. Then you run into amphibians. You remember our little friend from earlier that was still alive. You can, in the higher levels of the sediments in the softer sandstones, you could find many shapes and sizes of salamander bones. Now, the salamanders here lasted from 66 to 69 million years ago. Salamanders are carnivorous, and like today, some of them can reach 3 feet in length. They are the most common amphibians in that habitat at that time. Their bones are very, I don't know how else to explain it, have very many parts to the bones. Getting into the fish, you can find bowfin jaw plates, bowfin fish bones. They're an ancient group of ray-finned fish, recognized as living fossils. They are bimodal, which means more or less they can both breathe air and breathe water. Their teeth are oval-shaped and formed in one row, as you can see with the popsicle stick holding up a bone or a jawbone. They were carnivorous and quite large. The examples here is an example of a bowfin from the Green River Formation, so you had an idea what they looked like, at least back then, and a modern day bowfin. We also can find garfish, and then especially the garfish scales. It's one of the indicators when you're hunting. You know that you're in a channel deposit the moment you see a fish scale. They were also a ray-finned type fish, probably originated as full marine species during the late Jurassic. They were, of course, carnivorous. They can reach as much as 6 feet long. I have found scales in near Baker, Montana that were over an inch in size, so those had to be 6 feet long. They're the most common fossil found, that is their scales. They're characterized by long fangs. As you can see in the picture, there is one of the teeth, and they also have many small teeth. Next is your skate. A lot of us call them rays, but they're a little bit different from today's stingrays. The skates do exist today too. They lived during the Late Cretaceous with possible occurrences in the Paleocene and early Eocene. At least these species were. Found in both marine and fluvial deposits. There were carnivores. The teeth, as you can see, they were very flat and a very interesting shape. They fed on mollusks, thus you needed crushing teeth to do that. Their average size was around 3 feet in length. Next, we get into mammals, the therians. Therians include not only placental mammals, but also marsupials. This group leads to almost all modern mammals that exist today, including us. The marsupials were determined by their dennary. They looked very similar to today's marsupial teeth. They haven't changed and evolved much. Key marsupials of last formation are the Didelphodon, and I have some examples coming up shortly. And there are several other species. They range in size from a small cat to as small as a mouse. They were omnivorous and some were carnivorous, all depending on the environment they were surviving in. They were very much like the mammals of today, the opossums. In fact, some of their names were based on that. Didelphodon had quite a long life. Started around 73 million to 66 million years ago. They were omnivorous and carnivorous. They were semi-aquatic, and that's probably why this artistic rendition looks very much like today's otter. They lived along riverbanks and fed on mollusks, crustaceans, and small animals. They ranged around 3.5 feet in length and weighed as much as 11 pounds. They were named and described, at least the Delphodon, by Charles Marsh in 1889. The genus name refers to the characteristics of opossum teeth. They existed during the Maastrichtian age, and they went extinct after the KPG. The example here is a small portion of a jaw and several different teeth. Depending on where the tooth is in the jaw, their structure would be different. Next one is the multitubaculates, another type of mammal. They ranged from 69 to 65 million years ago. They were herbivorous or they were omnivores. They ranged in size from a small mouse to the size of today's beaver. The name described by Drinker Cope, they were named and described by American paleontologist Edward Drinker Cope in 1884. The genus name derived from the Latin roots referring to many tubercles. And more or less, you're talking the bumps in the teeth. You can see quite a few ridges on the tooth on the right, and they also have very pointed, strange teeth for the molar areas. They had their start in the Jurassic and survived the KPG extinction. And at that point, I'd like to thank you for coming and listening to me stutter and stammer. And if you have any questions, please ask away.
Thanks, Keith. Great job.
I have a question.
Be my guest.
The salamander that you found while you were digging, was that hibernating or?
It was live. It was moving. In fact, we took pictures, left it alone for a half hour, and it disappeared.
Was there water?
No. The water, we did find water in our dig site. You remember talking about the clays and the shales and the mudstones. Well, it seemed that it gave a barrier to the water to sink deeper. So what I'm thinking is they have burrows, just like any other critter there. And they would go into the burrows and they would have their water supply
So water would
filtered down through the sandstones.
Okay.
That's the only thing I can figure.
And even if it did rain for a while, it'd take a while for it to filter through.
Yeah. There was a place where I had found a nice size Triceratops vertebrae. I think along the rib cage. And it was so wet, it was embedded in the clays, the shaly clays. And I could literally grab a part of the bone and squeeze it in my hand with the clump. It was so wet.
Yeah.
And the freeze thaw was deep enough that it caused the bone to deteriorate into nothing.
The Brachiochampsa teeth, they thought, I mean, they're very, very much like the little teeth that I found that I think are fish teeth So now you've got me thinking, wondering if some of those teeth are not, um, maybe Champiosaurus or Brachiochampsa.
It all depends. I don't know if those animals were saltwater based, and I think maybe the teeth that you're looking at are saltwater. Am I
Most
right?
of them usually are marine environment,
Yeah.
but some of them, who knows, because it's material that's been moved down and into the, rivers and all that. So it's really hard sometimes to say.
Just keep in mind the Western Seaway was there and it was saltwater, but most of these estuaries were freshwater estuaries. Um, there, there was a deposit that I searched in the Lance Formation on a different ranch, and there was a conglomerate. And this conglomerate had very unusual fish teeth. I don't remember the species, but the teeth were about a half-inch long and curved and sewing needle pointy. And the environment there was so different. You could have all kinds of fish, and the only kind of fish I found in this particular Lance Formation we could identify as gar and could identify as bowfin. But the conglomerate, some of the teeth were very unusual. There are some teeth from the late Cretaceous that had very long teeth, like you see of the fish that are down deep in the ocean today. They were very long, pointy teeth.
Hmm.
Interesting.
It's got me thinking about some of the ones I've seen, and now I've got another area to explore as far as trying to identify them.
Yeah. Yeah. Interesting.
Keith,
Um,
thanks. Oh, sorry.
Hey, Jesse.
Good.
Hi. Thanks for a great talk. This is very informative. At some point when you were talking about the Nanotyrannus stuff, you mentioned the term, I think, dueling dinosaurs. Is that what you said?
Yeah, there was
What is that?
there's two dueling dinosaurs that I can recall. One is today in North Carolina. I think they prepped it. And then another pair from Asia, if I recall. Both of them were fighting. A herbivore was fighting off a carnivore. And I believe Lansiensis was one of the dueling dinosaurs that were found in the United States.
Cool. That's
Yeah.
awesome.
Yeah, look it up online. You can find pictures. They were preserved like
Sweet.
together, like an action scene kind of.
Cool. Awesome.
I believe Jane is in Burpee is Lethiensis, something to that effect. Always
Were
had,
the fossils that you photographed, are these all that you found?
yes. All the
Very
bone
cool.
fossils without association with image information is stuff I was lucky enough to find.
And were you on private land or was this BLM land or?
This is always going to be private land.
Okay.
BLM land, if you're looking for vertebrates, you're going to be wearing chrome-covered bracelets very quickly.
Yeah.
Uh,
Unless you're
Yeah.
working for a museum.
right.
Man,
Yes.
So you spent a lot of time on so a lot of the theropods and everything, because based on the teeth and everything. But what were they eating? I mean, you didn't seem to have as many of their prey, and usually they have to have, there's quite a few more prey to predators, and yet your fight is that because people are more interested in looking for theropods, or
We're always interested in looking for theropods, but most of the teeth that I find, ranking from the most to the least, most are going to be your spitters for Triceratops and Hadrosaurs. From there, you'll find probably a few more of your theropods like Dromaeosaurs. And the lowest number you probably find are your T-Rexes.
So, but again, if you've got a lot of these really small theropods, what are they eating? I mean, is there any evidence of
Mammals,
what?
mammals, marsupials.
And there's enough teeth to support that?
Well, you got to remember these are teeth do not represent numbers. All
That's
these
true.
teeth, on the most part, unless they have roots on them, are spitters. They've fallen out and gotten replaced multiple times. So just like the Serengeti Plains, what is the proportion of carnivores, predators, to your omnivores, zebras, gazelles, and the like? They're much lower. It's like 1 to 20, probably even different from that.
Yeah.
So the number of teeth does not necessarily represent the number of animals. And keep in mind, he's talking about spitters. Remember, your hadrosaurs had 1,400 teeth,
Mm.
and they're constantly being spit out and replaced.
So there's like a dime a dozen. You can pick them up anywhere.
In a channel deposit, in the right sections of channel deposits. We think where I was finding the teeth was a elbow in the river. So anything that was in the water column precipitated out. I have dry mouth, so I can't talk that well right now.
How did you figure out that it was an elbow in the river? Like, how do you interpret the shape of the channel deposit?
Well, you've been there. You can kind of get the feel of it. There is a curve to it before the section of it was eroded out. You ever watch the TV show where they're mining gold and different chunks of gold and different types of rocks settle out differently in the water column?
Uh-huh.
Um, so for small teeth to fall out of the water column, you need something to cause the water volume to slow. And that includes your big bones, but big bones are going to fall out first.
Mhm.
And they may fall out more in the channel than the smaller bone chunks and teeth and things like that.
Mhm.
So we think that it was an elbow which caused all those teeth and smaller bits and pieces to precipitate out of the water column.
Cool.
Interesting. Keith, you talked a little bit about the you said the Hell Creek Formation, the it's like a hard packed, you said gumbo clay,
Gumbo clay, yeah.
and then the Lance Formation is more like sandstone. Does the type of matrix change like the preservation of the fossils themselves?
It can have some effect and also can have the type of mineralization.
Yeah.
Lance wasn't known to have great red colored bones, but this particular site looks more like Hell Creek dinosaur bones than they do Lance colored bones. It's all mineralization and how they got preserved and what's in the sediments at that time.
Right. Yeah. Interesting.
Keith, was this
I'm fascinated by. Oh,
operation?
Yes, just so you folks know, this is paleoprospectors that we were participating with. In fact, I was just there for 2 days about a week ago.
Okay.
And
They had some of the heavy equipment.
what they did is, once they realized what they had, they got some heavy equipment to remove the overburden or some of the overburden. But you can't remove too much because it's a constant process of laying down sediments. So there will be periods in time where you'll have heavy rains, low rains, and how things precipitated out of the water column. So you can't dig too deep. Jesse and I were on that site about a year or two ago, and we were in the higher levels. And she was lucky enough to find a complete Triceratops vertebrae, including the neural process.
Oh, that's
Now, they excavated that area, and it seems that was the only bone found in that layer, but you never know what you're going to find.
Yeah. But you're not finding anything articulated because of the fact that it's been tumbled.
Yes, it is all tumbled. In fact, a lot of the bones that we are finding, the ends will have been broken off, eroded off, especially long limb bones and ribs. Right now, I have a rib in the ground that's probably about 30 inches long. It's a spare rib, and it's trapped on top of the clay layer. So hopefully come this May, I'll be able to get the whole thing out. But it's very rare to find a complete spare rib because it gets tumbled so much.
So are you able then to kind of cordon off an area that's I'm digging here?
In this case, Mike was kind enough to let me cover it with aluminum and bury it with sands, and he's not having anybody dig there. And hopefully I can find more bones. There's, I think, a partial turtle shell that is probably about 8 inches long to about 4 inches wide at one of the corners, but it's perpendicular to the flow. So I don't know what I'm actually getting myself into.
How is it to prep?
A lot easier than some of the more stuff. All depends. The hard part is when you're working with these hard clays, the clays break up the bone.
Yeah.
There's no easy way to get it out of the ground. One of the things I'm going to try doing this next round with this rib I want to work with is I'm going to take my diamond saw to cut around it, wedge around it to see if I can get the clays to break evenly, which is almost impossible. The preservation is great in the sandstones, and I'd much rather have it be in the sandstone, but that's in life.
Yeah.
So how does this compare to looking in some of the other places you've been digging in?
I've done Hell Creek. All the environments are different. Over near Glasgow, the hills are not hills. They are very vertical valleys, and that's the kind of thing you're walking through. The sediments are different. Like we said earlier, lands formation is a lot of sands, which helps the preservation in many respects because if it's in a sand, it's not stuck to something and the sands can be more easily removed from around the bones. I was at the Morrison Quarry, a Morrison Quarry near Bighorn Mountain, and there was some very nasty hard layers of like limestone or limestone like sandstone. And underneath these hard layers, we had very soft sands. Well, what happened to the bones? The bones that were attached to the hard rock got broken up in order to get them off the hard rock. It was so bad that there were Allosaurus teeth attached to the hard rock in which we would go and have to take diamond saws to cut the hard rock and have it presented on the rock instead of taking it off. So the environments in which they were found in, the sediments were very different depending on the locations. There's even in the lands, there was areas where we had conglomerates, which were kind of cool. There's conglomerates up in Montana. I had found a fibula of a triceratops about 30 inches long that I still have to prep. Under that was a conglomerate layer. And there we hadn't had a chance to really see what was in it. I know that there was some rib bones underneath that fibula. And I'm very curious and hope to find out come July or August, I can't remember which now, what that conglomerate consisted of. Channel deposit are really very interesting. The sediment layers change over time and depth.
Very interesting. I'm really curious about the one where they found the teeth, but they've never found the jawbone. It was one of the theropods. They've never found the jawbone with the teeth in the jawbone. And I didn't understand on the other one, and I didn't write it down, where the teeth were coming through these channels. I mean, there was one where, and I didn't
Hadrosaur.
quite understand that one.
Let's see if I can get the picture back. Kind of think of it as like a production line. Come on, there we go.
Okay, because I know how the mammoth teeth will move down, and we learned about that. And then other ones, like the shark teeth will fall out, the front lines will fall out and they'll come forward. But I didn't understand the channel aspect. Yeah.
The tooth as it forms, kind of think of it like human baby teeth. You get one tooth and then the other tooth, the older tooth gets pushed out by the younger tooth. So the root may be about this deep into the jaw, and then it sticks out of the jaw above it. And then you have your gum and gum line. But underneath that tooth, another tooth is forming.
Okay.
So
But
as
these are self-sharpening.
they're
I mean,
shell,
because they don't look like they have that the same long root. And that's why I was trying to fit it into that jaw. And it's like, wait a second, I'm missing something.
the self-sharpening is more related to the upper jaw with the lower jaw. And when they bring their jaws together, the teeth are sharpening each other. Kind of like your scissors. But in case of our scissors, it's two pieces of metal brushing up against parallel to each other. In this case, there's a subtle overlap, so the teeth are touching each other, constantly sharpening each other.
That's real interesting, though. I mean, yeah, very cool. Do they have any jaws with the teeth still in the channels showing that growth? Or is this, I mean,
There were a few found. I'll give you an example of what was found in this particular channel deposit. Pachy, Pachyderm was found. There were several jaws found, both Triceratops and Hadrosaur, Edmontosaurus. The jaw here that I have, I found that in the Lance Formation, not this particular, channel deposit. Mammal jaws have been found with teeth. So Didelphodon, I believe, was found. There was a rooted Troodon tooth found, but I don't know if there was a jaw found. So it all varies. It's a very unusual channel deposit, to say the least, because of the amount of number of different animals found there. In fact, I have an example of plant material that I found. Usually you don't find but bits and pieces. I have a complete stem or bud of a plant in the shales.
you also mentioned there was a lot of coal in that area.
25% of of all the coal found in the United States is found and dug up in Wyoming.
We
There,
don't see a lot of fossils, from like what or concretions like we have around the coal, over by Mason Creek.
I don't know if there's concretions there or not. I've never went on a tour to find out.
Uh,
But they even have tours out of Gillette. You can go to a quarry and see all the huge equipment. Nice.
it's so hard. I mean, again, you've got this desert environment, and then you see all this stuff from a coastal, and then the coal, So, at one point it was definitely a whole different environment and all in the same area, where the environment has changed so much.
To be even more unusual, I'm trying to get to where I want to be. Get back to my maps. Ah, here we go. Notice a town called Upton. There, I haven't gotten to go collecting because we don't have any ranches to be able to go to. They are finding marine animals there from the Western Seaway. So here's Newcastle down in the bottom, and up in this corner is Upton. So we're going from fluvial to ocean environments in this short area, and within this about an hour, 15-minute drive. Now, I can't remember what carnivore was found. There was a rock show a few years ago in Gillette that I went to, and these folks were selling not only Triceratops bone chunks, but they were also finding things that were saltwater aquatic animals. Ichthyosaur? No, I can't remember the name. I can't. Pardon me?
Mosasaur?
Not the same family, but the same jaw. It had large teeth. They were about 3/4 of an inch long, and they were a carnivore's jaw part. And I'd love to be able to hunt that rancher's property, but being able to do that was not possible. A lot of these ranchers have all kinds of bones in their barns and their garages from just being ranchers and finding things along the way.
I don't want you on the property.
Yeah.
Is the coal carboniferous?
This coal line started in the late Cretaceous, and the forest lasted into, I think, the EOC.
I mean, it's not carboniferous at all.
No, it's low sulfur coal. It's very desirable coal. It's probably why they had laws set up in Wyoming saying that carbon dioxide is good.
We've had a couple of people that have to leave, and they've said, thank you very much. I enjoyed your presentation, and I agree with them.
Yeah.